For my API research, I picked web storage. Web developers have traditionally used the JavaScript cookie object to store information in key value pairs on the client. The Web Storage API provides two new ways to store information on the client side, which is local storage and session storage. An advantage to using web storage is the increase in the amount of data that can be stored, which would be 5 megabits per domain. The local storage object stores data without an expiration date. The session storage object stores data only for the duration of the current browser session. JavaScript is used to work with the values stored in the local storage and session storage objects. Some example for web storage objects is window.localStorage, which stores data with no expiration date, and then window.sessionStorage stores data for one session. Data is lost when the browser tab is closed. Local storage says, create a local storage name or value pair with name equals last name in parentheses and value equals Smith with the same element. Retrieve the value of last name and insert it into the element with ID equals result. Each storage object provides access to a list of key or value pairs, which are sometimes called items. Keys are strings. Any string, including the empty string, is a valid key. Values are similarly strings. Each storage object is associated with a list of key or value pairs when it is created, as defined in the sections on the session storage and local storage attributes. Multiple separate objects implementing the storage interface can all be associated with the same list of key or value pairs stimulously. The length attribute must return the number of key or value pairs currently present in the list associated with the object. The key method must return the name of the nth key in the list. The order of keys is user agent defined, but must be consistent within an object so long as the number of keys doesn't change. Thus, adding or removing a key may change the order of the keys, but merely changing the value of the existing key must not. If n is greater than or equal to the number of key or value pairs in the object, then this method must return null. The supported property names of a storage object are the keys of each key or value pair currently present in the list associated with the object. The getItemKey method must return the current value associated with the given key. If the given key does not exist in the list associated with the object, then this method must return null. The setItem or key value method must first check if the key or value pair with the given key already exists if the list associated with within the object. If it does not, then a new key or value pair must be added to the list with the given key and with its value set to value. If the given key does exist in the list and its value is not equal to value, then it must have its value updated to value. If its previous value is equal to value, then the method must do nothing. If it couldn't set the new value, the method must throw a quota exceeded error exception. Setting could fail if the user has disabled storage for the site or if the quota has been exceeded. The removeItemKey method must cause the key or value pair with the given key to be removed from the list associated with the object, if it exists. If no item with that key exists, the method must do nothing. The setItem and removeItem methods must be atomic with respect to failure. In the case of failure, the method does nothing. That is, changes to the data storage are area must either be successful or the data storage area must not be changed at all. The clear method must automatically cause the list associated with the object to be emptied of all key or value pairs if there are any. If there are none, then the method must do nothing.